All right. Thanks everybody for joining. We're going to be talking about IR welding. You can't touch this. IR welding is used when you're not contacting the plastic parts to a heated tool or something like that. I am Jason Dornbos. I am sales manager at Extol, and presenting with me today is Nick Flesher.
Yep, and I am director of technologies and innovation.
Let's get started, everybody. Party time. So, why did you join this webinar? Everybody on the chat, let us know why you are on this webinar. Do you just love seeing us, or do you have something specific that you're hoping to learn?
If you can, we'd love to hear actual problems, actual challenges that you've had, experiences. So we love, great. I'm starting to see, looking for new technology on IR. We're definitely going to show you some of that, Max. Another company's in the mix and just wants to learn about the technology. Fantastic. So the more you ask, the more you engage, the more fun we have, the more informative our webinars typically tend to be. Yeah, great. So we love A, B, C, sort of. My favorite. This is one of my favorite questions to start up. I see an F. We have someone who's humble. I always love the A pluses because that makes me nervous in presenting. Design constraints, fantastic. Seems better now. Great.
Yes, awesome. And I'm glad. Thank you for that feedback, because I have been on a webinar before where the presenter was presenting for 5 minutes without sharing their slides, and no one knew. So we want to make sure if something's wrong, we want to know about it.
Yep. Awesome.
Let's get going. So apologies if you've heard this from me before. If you've joined our webinars, you've seen these slides, I think. But we want to get it ingrained in your heads. Extol solves complex plastic manufacturing challenges. That's what we're all about. We're solving problems that other companies can't solve. If you look at our logo, it has a kind of a graph in it. On one side of the graph, there's companies with plastic welding expertise. These people know plastic welding really well, and they know how to make a standard machine. So if your part doesn't fit inside of their standard machine, you need to branch out and find somebody who makes custom automation. Custom automation companies, they don't have plastic welding expertise in most cases. Extol is the best of both. We have plastic welding expertise and we have roots in custom automation. So those two things together, we can provide a total solution for you. That breaks down like this. We have engineering services because we're trying to help you solve your plastic joining problem. We can help you with development. We can help you with 3D printing so that you can try things out. We can help you with prototype and validation. We do this all the time. We have a fully staffed lab where we're doing this daily for all kinds of companies. We have plastic assembly technology. We're going to talk about IR welding today. But in addition to IR welding, we have hot plate welding, spin welding. We can integrate ultrasonic. We can do, we have some staking technologies. We'll go into some of those things. And then we, of course, have custom automation expertise. We can provide you with a fully automated cell. Think multi-million-dollar lines where robots are moving everywhere and parts are being handled going in and out of machines and all this stuff. We've built cells like that, and we have built standalone machines where somebody is literally walking up to the machine, putting a part in it, it runs, and then it comes right back out. Simple, and everywhere in between. And then, of course, all of these plastic assembly technologies can be integrated. So if you have your own automation capabilities and you want to take a laser welder and put it into your automation line, we would build you a laser welder that's made for integration. It will tie into your line, and it'll be configured specifically for you. Is that fair?
Yeah,
okay.
That covers what we do. So plastic welding, you need two things. I'd like to kind of open this up. Would anyone venture a guess on what those two things might be to weld plastic together? We'll pause for a moment. Plastic. We're talking specifically plastic. There are two main things you need.
Anybody? Plastic and energy.
Plastic. Okay. You do need to have plastic. That's very fair.
Yeah.
Energy is a really good word.
Yep.
It's a really good word.
Probably better than the word that I have.
Probably better than the word that we have.
Heat. Yep. That's another.
Heat.
That's heat or energy. Okay. And then the other one. What else do you need?
First with a
or an F. Pressure.
Pressure.
Boom.
That's right. Or an F. So you need heat and you need pressure. There's a lot of nuances to welding. If you join this, you're in the plastic welding space. Downstream of the molding. There's a lot of process parameters depending on the welding technology that you're using. But at the basic level, you need heat and you need pressure. So infrared energy is a form of heat. It's one of 3 heat transfer methodologies, and we're talking IR today. So just a little bit longer wavelength from the visible light spectrum, and there's multiple wavelengths that we're going to talk about. A lot of the wavelength emitter wavelengths out there are in the broad spectrum, but you're working in the near IR, about right in the middle, 900 or so and up. And so you have to make sure that you have the right infrared wavelength so that you're getting that power absorbed into the parts. So we like this visual just because it's sort of, electromagnetic waves are kind of a weird thing. You've got gamma rays all the way, the bad radiation on the left. You've got radio waves that are zipping around all around us. We're focused on the IR spectrum, and we use, around 800 up to 2 micron, or just sort of to the right of where that says IR wavelength spectrum.
Sometimes when we say radiation, people think, ooh, that sounds very harmful.
Yeah.
But radiation can be any one of these wavelengths can radiate. And the harmful ones are sort of in this ballpark over here. We're in infrared. It can warm things up.
Yeah, that's right. All right, let's talk IR sources. So we use, at Extol, 4 different types. And this is, there's slight variations depending on other manufacturers, but straight IR emitters, and we'll use a couple of different wavelengths for that. Those can typically be pretty high power. They are really good at getting energy sort of everywhere. And so we'll talk about pros of when we use these. The second one is custom. Custom quartz emitters are customized shapes. So you can kind of see here, this is following a weld joint. We're going to talk about welding, embedding, some other type of methodologies with infrared welding. But this is just sort of a visual of a custom emitter. These have some cons. They can be kind of costly. Evenness of melting can be a challenge. But in some cases, it's really kind of the best approach for wattage versus length. One of our technologies that's proprietary to Extol is called InfraGuide. We use these emitters in our staking technology, in our infra-welding technology, which is like spot welding, and then to hit various widths of weld ribs and embedding systems. So InfraGuide emitters like this are really point emitters and are pretty robust, very cost effective, on the shelf, easy to get. And we've been using these bulbs for over 20 years. Whew. Technology works really well. Mm-hmm. And then lastly, we've got laser energy. So we will use 1 micron wavelength and 2 micron wavelength. Power levels can range depending on your budget, size of parts, cycle time. And we may go from 50 watts all the way up to 800 watts of power, depending on the wavelength and what kind of speeds you need. Again, heavily dependent on the application.
1,000.
1,000 watts? Yeah. We could do 1,000 watts. We typically try to stay, it's a good question. We try to stay in the air-cooled laser source. We've got a supplier that provides a really robust air-cooled solution. They can do water-cooled over 1,000 watts, but most often plastic can't absorb that much heat anyway.
Oh, yeah.
Yeah.
Makes sense. Okay.
So to the pressure side of things, pretty simple. We're not going to get into detail. These images just sort of show, we're using pneumatic pressure presses, servo presses, very often servo if you need that precision. We've used hydraulic as well. Maybe not so much in the IR welding space like what we're talking about today, but for laser welding we've had to use like really high pressure for really high surface area welds, but just typical presses to apply that pressure. All right, let's talk a little bit about what we do with the energy and what matters per technology. For quartz, for both sort of methods that we showed you with both examples of emitters, typically that energy needs to be masked. Most applications, you need to make sure that energy doesn't just go everywhere. And so, mask can be lightweight. We've even done some energy directors via mask. We have to make sure those stay cool. But one key element, if you've really sort of wrestled with masks, make sure that those masks get as close to the part as possible. We've actually engineered masks to clamp parts because oftentimes plastic isn't flat. That might be a shocker to everyone on the webinar here, but
why would it not be flat?
Yeah, plastic can be kind of funny that way. So that's just one thing we've learned over the years. Your position of your mask, obviously the geometry of your mask, all sort of matter as far as how efficient that energy gets from the emitter down to the part. What you'll see on the right is our InfraGuide product, sort of a cutaway, and you'll see videos of that weld process in a moment. But that energy is extremely focused. We actually optically engineer each InfraGuide that we use, and we get really uniform distribution, really focused distribution. Sometimes we process with the concentrators, what we call it, we're concentrating the energy down under the weld rib. In most cases, we don't need to do that because all that energy is going immediately to the weld rib. Even on a properly engineered masked IR weld, you can kind of see that it's a little bit outside of the weld rib, which might not be acceptable. So a couple different methodologies, and again, we through Jason's discussion of our engineering team, our applications team, we work with you on which is best suited for your application and what your needs are.
The other thing that's happening here is, this is showing what some of the light, like obviously there's some light here that's going this way and some light here that's going this way. There's also a lot of light that's doing this, a lot of energy that's just stuck back here, kind of wasted.
Yeah. So the efficient, that's a really good point, Jason. And we'll talk about with quartz, in some cases it really works. You might have a whole bunch of surface area and really trying to get that to a whole, a lot, using those quartz emitters because there's a ton of energy available. But in most cases, we find that InfraGuide, if the parts are small enough and we can design it well enough, is just wildly more efficient. Like in some cases, like 20% of the energy of a quartz emitter. So we'll go ahead and show a video of our InfraGuide technology. We're going to talk InfraGuide a little bit more in a minute, but this is the process, so you can kind of see a tool in the works.
The flickering is actually intentional. That is a way for us to reduce the rate of heating. We're flickering to reduce that power output. You can see it's a nice, beautiful weld joint with nice, consistent flash.
So one thing we don't really have a slide, but it just prompted me to talk about, Jason, is when do you need IR welding, right? Sort of the pros and cons of, the title is you can't touch this. Well, a lot, some plastics with hot plate welding, they're not friendly. They might be really sticky. Or for vibration welding, they might be really dirty, a lot of dust, a lot of particulate. Similar to hot plate. That's exactly right, Dimitri. This technology has two emitters, and we're heating up two parts and then pressing them together. So the process looks very similar if you don't look at the tool. And we're actually going to talk about a welding platform that does accommodate multiple technologies because you need the same process control on the press, the pressure. That second thing we talked about. Back to the reasons that we see infrared might be the better choice. You can kind of see here. This is actually a glass-filled nylon. If you've ever worked with nylon, that it can be kind of sticky. It can create a lot of dust. Dimensionally, it might not be very stable, which we can actually clamp with our InfraGuide tool. And so this weld rib is actually quite remarkable with these materials. It's a really good-looking weld where we were able to heat the plastic in a way that helps us to weld with a high quality and high force. So I think the next video is quartz. If you've not used quartz emitters, this is actually a bank of a very uniform bank. There's a lot of power here, and the reason for that is a lot of linear weld ribs. This was a part that had kind of went back and forth. I think there was probably 9 or 10 welds with like internal welds and things like that. Our mask tool is actually quite thick, So we'll go ahead and play this video so you can see this. Well,
quick, before we play this one, the previous InfraGuide, can this work well for different contour heights in the Z direction?
Yes, it can. Great question. There's not much, but you can see a little bit of a angle rise. I think the other end of this part was actually at a 40-degree angle.
Yeah, in fact, if I go like, hold on, get rid of laser pointer. Here we go. Right, you can kind of see it right.
Oh yeah, on the bottom
here.
Yep.
That's like a 45-degree angle, kind of going away from you as you're watching this. So like the part weld line did a 45-degree drop over there. You can't see it up here because it's going down. But here's where, and so I was able to do that and work well.
Yep, great question. We'd love to see more of those questions as we go here.
Yeah, keep them coming.
So we've got our customers' parts blurred just to maintain confidentiality with them. This is one where we actually did use a little bit of combination of focus on the mask tool, and we actually had to clamp it. So that's why it's so thick. Jason, you want to point out the mask? There, you can see that.
This is the mask right here. Well, it's going away.
Yep. This is actually going a bit slower than what we would want to do in production. We have a parameter at Extol. A lot of companies call it different things, but at Extol we call it open time. And the faster, typically if you need to use IR welding, the faster you can get that power away from the part and the parts together, the less time it has to oxidize, to skin over. And so this one's running at a slower speed.
Yeah. It looks slow, but it actually can be fast.
We usually shoot for infrared welding, usually shoot for 3 seconds or less. In some cases, we can hit 1 second. We had a PVT application. If you have ever worked with PVT, it's pretty nasty plastic. Where we were running, I think, 1 second.
There you can kind of see how the mask is a little more focused than just a simple flat mask.
And that was a very thin part, so we had to clamp it. And so we were clamping, we were focusing energy. So a couple of tricks that we feel we haven't really seen many companies doing that, using tools that actually help to focus energy, mask tools to help focus the energy. And you can also hold them rigid, so you don't have parts sort of flopping around and getting different energy with a straight emitter.
Yep.
So.
All right.
We're going to talk direct laser welding. This is an application where we were using, it was like for fluid distribution. It's kind of a manifold, but direct laser is using a laser source, kind of showed that at the beginning, and we're hitting multiple spots. So you're going to see a video with multiple paths. You'll see the energy source. It's got a filter in the camera. It's not visible to the human eye, but you're going to see the laser bouncing back and forth. You're going to see a lot of smoke. You haven't seen a lot of smoke in these videos. Infrared welding can produce smoke, so you do have to manage that. For the production application on this one, we just had a duct that pulled those fumes away. So for other laser plastic welding, you don't have smoke, but that's for through transmission.
The other thing to point out is the frame rate of the camera limits what you see, so it looks kind of choppy. You can tell it's fast, but the frame rate is only picking up just bits and pieces of how quickly that laser is.
Yeah, it's actually a spot. So what you see in the video is it might look long, and I don't know what everyone's internet speed is. What Jason's showing there is really good. Mine's a little choppy.
So this is. I think the frame rate is probably 30 frames per second, and it's that one frame in that 30th of a second. That's how fast that beam was moving around this. This is a single spot going shoo, all the way around that little oval.
Yep.
That's how quick it's moving.
Yeah. So this is direct laser welding. We're heating up. In this case, there's sort of 4 parts. They look like 4 parts, and then we're pressing them together. You get that pressure with the table pivoting and pressing. Are there specific part design or material limitations that must be considered when using IR laser welding? Absolutely, Karina. You need to make sure that the plastic has the proper absorptive properties for the wavelength you're using. So, for example, for laser direct laser welding, 2 micron actually doesn't absorb that efficiently in plastic, but it's pretty uniform. And so you can get more color variation. We have a customer that has a gray part, and 2 micron gives them just the right heat affected zone, just the right amount of energy. And that was what they wanted. 1 micron was actually too surface oriented. So 2 micron actually soaks in a little bit more. Not all the energy is absorbed at the surface, whereas 1 micron is very, very surface absorptive. And as you see here with the black, you can kind of see a little bit of a blur of a heat effect on that left bottom part. It's a little blurry there, but yeah, you do have to
turn color.
Yeah,
and darker.
And we're happy. Yeah, it kind of is a little cloudy, but we're happy to test that. It's a great question. You must have run into that before. So just be mindful of that. And really, with all infrared energy, you need to make sure the plastic's going to absorb that energy, and we can help you with that. InfraGuide's probably the best from broad spectrum. A lot of visible light, which actually doesn't generate the heat. But that covers a wide range of wavelengths that the plastics like.
Oscar asked about integrated exhaust system. So we often will, for a solution like this, we have ports and blowers and suction to try to manage the fumes and get them out of the machine, and then get them into a tube that can be connected to a plant exhaust system. They can also be connected to an air scrubber. If you're not exhausting them out of the plant, you can run them through a scrubber so that they don't make everybody sick.
Yep. So a couple other questions. Great. I see. So you're using laser to heat both pieces and bring them together. That's exactly right.
And it's different than clamping a transparent part, although it's similar because we're using the 2 types of wavelengths that you would use if you were doing a transparent part.
Yeah, we do see that we get more through transmission laser from an application standpoint. That's definitely more common in the space, but this was actually an application that was designed as ultrasonics, but it wasn't. Except there were feasibility challenges that had what's called far field welding, which is really another webinar.
As far as vacuum, we need some way to retain the parts into the nesting, just so that when you flip, they don't fall out, and also so that they're seated all the way. You can use vacuum. We can use mechanical clamping. There's lots of different ways that you can hold it in. You wouldn't necessarily require vacuum, but it's often the simplest solution.
Yep. Sometimes detents. I think this was actually a prototype version. We did a production tool. This was I think just detailed or detents.
A spring-loaded thing. Peak.
Yeah. So the answer is that's a tricky material, as you know from probably asking it. I have seen InfraGuide be used for that, but the melt times are very, very long, particularly if it's natural. So I think the I think Peak's quite high in hygroscopic properties, so it really sort of sucks up moisture, which can be a bit of a challenge. You do need to make sure that material is dry, and typically running right off the mold. So a tricky one. I would love to go deeper into that application. So if we can, we'd love to reach out to you on that.
We should park on that for 1 second longer. Not necessarily peak, but hygroscopic, and how moisture in plastic parts affects IR welding.
So, regardless of the energy method that we're using, if there's moisture in the part, as you come up to melt temperature, that is, what you need for welding, the water will boil, and so you can create voids, which then lower weld strength. The water kind of acts as a contaminant. So typically, we see that it's not too much of a challenge if it's run right off the mold. You have to dry it to go into the molds anyway. And so the quicker you can kind of get that through the welding process, the better. Some customers, it's a high humid environment, but it definitely can affect the welding process.
And not all materials are hygroscopic, right?
Yeah, that's right.
Okay. Yeah. So some of them will absorb moisture, some of them won't.
Don't test me right now.
Okay. Here's the list of...
How does total cycle time compare with hot plate welding, vibration welding for each IR emitter type? Excellent.
Are we going to get to that, though?
I think we are.
Okay.
Park that, Tony. Good job. Thank you.
Weld strength.
Compared to quasi-simultaneous welding.
We need to get to the comparison slide.
Yeah. Let's do that.
Look at that. That's the next slide.
Okay. Fantastic. But we don't compare with others. So I will just say, generally speaking, IR welding can be a bit longer than certainly vibration. Vibration is really fast. It's come down friction and press. Comparable, it depends. It can be comparable to hot plate. So you saw the video of InfraGuide real time. We've run black parts with melt times in the 10 to 20 second range. We've run white parts with 22 seconds. So that's a little bit longer of melt, but it's it all depends on how large your parts are, how dimensionally stable, how absorptive they are, what your strength requirements are, how much heat effect is on. We had a company that really designed a part for hot plate welding, but then it was PPT. Those things don't go together. And so we had to pivot to InfraGuide. And I think we had to have a weld depth of like 70 thou of an 70 thousandths of an inch. So they needed like a 30-second melt time. We had to just go low and slow. We had to dial the emitters way back. So it's a great question. My favorite answer is it depends. But I would say, generally speaking, direct laser is probably the fastest, maybe comparable to InfraGuide. Quartz is probably next from a speed standpoint, and then non-contact hot plate welding can generally be the longest.
Slowest
for melt time. Seal times for us typically are all the same. We try to do 5 seconds. Sometimes you might have a part that needs to be sealed a little longer. But let's compare across these technologies just as you run across them. Quartz IR, InfraGuide, non-contact hot plate welding, which is basically like hovering. Usually we want temperatures above 900 degrees Fahrenheit. And then direct laser, you saw a video of. I don't think we had a non-contact hot plate welding video, but that is sort of that looks like hot plate, and you just park out.
Get real close.
The goal is like under 60 thousandths of an inch. If you go over 60 thousandths of an inch, you kind of get an exponential increase in time. So we do have customers that do struggle. They can then, from a dimensional standpoint, get on the upper side of that. Material color, Quartz IR, really all but clear. We have even done some natural, but for full transparent, that's really tough. We have successfully done like Ultim and other challenging materials with InfraGuide that are fully clear. Same, non-contact hot plates, similar to Quartz, and then direct laser. Again, with that different wavelength, we can do all but clear. Energy control, masked versus focused. We use distance on non-contact hot plate and programmable. By the way, this tool, it's hard to sort of describe this quickly. We're going to send you a copy of this presentation, and you can kind of digest this and think about it for your applications. Energy uniformity. This is really why we developed and invented InfraGuide. We had done Quartz IR, and it can be tricky to get it uniform. So the word moderately there is strategically placed. Tunable, uniformly distributed. If it's not uniform right out of the box, we've even taken vibe welded parts that had to be converted, and the customer was like, we can't change our mold, and had really fat corners, like almost double the width. And we just turned those emitters, all the other emitters down, and got completely uniform, even though the thermal mass was not the same. Say non-contact hot plate welding is uniform, but it is positionally dependent. So where that part sits distance-wise can really matter. And then direct laser, you can dial it into whatever you want. Sensitive applications, we don't really recommend Quartz IR for that. I think just because there's so much energy there, and even masks can get really high temp, like 600-700 degrees Fahrenheit. InfraGuide, really safe to use. Typically, I would say in all production applications we have, they're air cooled, and we've had PCBs directly adjacent to the energy emitter. So the InfraGuide itself. Definitely still dimensionally dependent for hot plate. Direct laser, you're not heating anything that laser doesn't pass, so it's definitely safe to use. We haven't talked about flare-ups yet. If you're new to the IR welding space, that might sound confusing. If you've done IR welding before, it can be a thing. Probably more than all these would be non-contact hot plate welding with certain resins. Typically in the nylon family, the off-gassing can be flammable. And so, we say there's a medium risk because we have mitigated that before with things like nitrogen or, the parts will self-extinguish.
Mm-hmm.
The part actually isn't burning. It's what's coming off while you're emitting.
Mm-hmm.
InfraGuide has none. And the reason that we want to park on this for just a moment is we actually cool the tool with air that pushes all of those fumes away from the weld rib and away from the emitter. So just kind of keep that in mind. And it's not all resins. There's some resins that that's not really a thing, but we can definitely help you with that.
Okay. Some questions. How are we controlling the input power to the IR bulb? So we have power supplies so for InfraGuide, we have power supplies they're controlling the power of every single bulb independently, and each of the bulbs is 100 watts. And then we use pulse width modulation to reduce that power output. So as we turn the power down, the pulsing gets greater and more off time than on time.
We found that the key to processing is matching the absorption of the energy at the surface of the part to the ability of the plastic to conduct the energy into as deep as you want it to go.
Mm-hmm.
So that's sort of language that we use here from a process standpoint. You want to get that energy. If you just melt the top and you got to push everything together, all of your good semi-molten material is gone.
Yep.
And with Quartz IR, we use phase angle SCRs is what they're called, but they're just power supplies that can be adjusted up and down. But the key is, as Jason said, we can dial in those bulbs individually on InfraGuide, whereas Quartz is kind of what the emitter.
You got to do the whole bulb at a time,
Yep.
at least. Yep.
The limitations regarding part size, thickness, and design when using iron energy, any quality risk, deformation.
Direct laser. How big of parts can you do?
Yeah, so I think go next slide there, Jason.
Okay.
What I would say is for Quartz IR, larger parts are more. We find that we sort of shift to quartz for emitters when the parts are really large, or the weld ribs are internal, and we have to. With InfraGuide, you can't really design it so that since we're using a focus tool, if ribs are really close together. It's a little bit better to mask the energy and use the quartz. So there are, I'll just say this kind of as a general, you'll see that we don't have specifics in what we're going to show, but our applications lab really needs to work with you on that because we've done everything from thin films to like panels, like extruded panels welded to parts to manifolds, which are really rigid. Medical devices where, microfluidics, really, really sensitive. So, this is a pretty high level webinar where we're just sort of introducing the ideas. I would say we absolutely want to make sure that there's not deformation or, you're overheating the plastic. Laser's really good if you have a very sensitive application where you can't put excessive heat into the rest of the part. You just want it at that weld rib, right? So, that's a pretty bad answer. I don't like that answer. Great question. Excellent question. I didn't like my answer. But what I would say is as we choose technologies, that's first and foremost in mind. And then as we validate them in our applications lab, we're making sure that it's meeting your standards. Yeah. It's kind of the best way to say that. Films. Films with PEEK are tricky. I would say we've done some non-contact hot plate welding, like using a heated tool for that. We've done through transmission with heat, so kind of tricky. Yeah. Okay. Sweet. Maximum size can be welded. Example: automotive lamps, lens, housing, subassembly. Which is better to be part of the welding application? Oh man. So automotive lamps.
Run through these.
Yeah, let's
talk about sizes.
Yeah, we do. Yeah. So Quartz IR, large parts, internal ribs, blanketed heat. Kind of think of it that way. You can use it that way. That's how we've used it. We've also done custom emitters, but we really have shifted to InfraGuide for that. Sensitive parts can be tricky because you got so much power, and when energy control needs to be considered. InfraGuide, medium, I would say small, medium, and even the part that we showed the video of is probably 18 inches. Yeah. Or so. But so we'll say medium size is what we would call that. We've had our sales team bring pallets, like big 4 by 4.5 feet parts, and that's no good. Just way too many bulbs. Sensitive parts, it's excellent for that. Complex weld profiles, precise energy control, and it's really, really efficient. I would go so far as to say more energy efficient than hot plate welding. Probably not quite as much as 5, but doesn't work great for large parts and internal weld ribs. And you still can do some internal weld ribs. I want to be very clear. The challenge becomes if you have a lot of internal ribs that are really close together. Think like less than an inch, apart.
Because the reflective geometries that we're using to get that energy focused onto the weld rib, those run into each other when you have really close weld ribs.
Yep. Non-contact hot plate welding work pretty well for large parts. So to the question that was asked, we have done some lighting sort of applications. Really large parts because you're using energy that is sort of, I'll say, cheap. Contact heaters, really aren't quite as costly as Quartz IR that are custom shaped. You can get more complex weld ribs. So you can hit a 4 foot, 5 foot wide part if you need. The part becomes a bit of a challenge because holding it dimensionally consistent and the right distance, because that space is so important, that can be a bit of a challenge. But internal weld ribs, because that energy you can essentially it's a machine detail at that point. Complex weld profiles, sensitive parts, we'd say it's medium. We have done some different LEDs and printed circuit boards and things like that in these applications. And we'd say inconsistent parts are a challenge. Direct laser. Smaller parts are better. Sensitive parts for sure. Intricate weld profiles, things like that. Loose internal components. You do, as you saw, you kind of have to get parts together. And, so you do have a rotational part. We have, done this approach before where one part that had some components inside are fixed. And then a cover is going over top of those parts. Larger parts, laser energy is not as cost effective as these other 3 technologies. And so we can use, and we have used, multiple laser sources and scanners, but cost-wise, it starts to go up at a different rate than the other 3.
The part gets big, we'll just have multiple lasers bouncing around, but every single one of those lasers costs money. So.
Question. Since you're pushing material after heating, how do you control flash, if any? Great question. Sometimes it's on depth, basically. Yeah, you want to...
I was going to say that. So it's all on depth. The parts coming into it have to be relatively consistent. And then when we bring those things together, we measure the displacement that we're doing on the part. And so we can make sure that the displacement is consistent. We can't change how much material was there to start. So
I would say the follow-up question was flash traps. Everyone know what flash trap? Well, you can't answer me.
They can answer.
They can answer. Flash traps are or conceals are essentially details that you design into your part where the rib is sort of inboard of the outside of the part. So you can't really see the flash. We've shown it, in the videos you've seen some of the flash. So we've very effectively used flash traps for InfraGuide for direct laser. We've even done non-contact that looked excellent. It's an image we'll show you in a minute. Quartz IR is a bit more challenging. You have less control of melt depth or heat affected zone, and kind of you got to just press them together, as Jason said. If you don't have a good weld and you aren't pressing enough together, then you got to press harder. We're going a bit long here, Jason.
Are we?
I tend to do that.
Okay. Well, I was just going to say real quick, before we dive into some applications, we've talked a couple different times about through transmission welding. So the difference there, you have direct welding. That's what, when we say IR welding, typically what we mean is a direct style of IR welding versus through transmission, where the energy, the IR energy, is going through one component and being absorbed by the other. The way these technologies break down, Quartz IR, I'm going to use my pointer here, Quartz IR, all of these are direct welding solutions, but some of them can be used for through transmission welding. We have used InfraGuide in through transmission applications because we can control these reflective geometries, so we can design the tool to focus that energy through a part if we want to. And then laser welding, it's very common for that to be a through transmission laser weld. In fact, it's more common in the through transmission space than it is for direct. All right, so some applications. Quartz IR, there's lots of different places where this can be used and where it's really well suited. Instrument panels, so those are automotive instrument panels or like heavy duty truck instrument panels, those things that you're like your dash of your car. There's lots of things welded behind that, and those are often done with Quartz IR. Air ducts inside of engines, or not metal air ducts, obviously plastic air ducts. Fluid reservoirs, glove boxes, that's what's pictured there as a glove box. Those are often Quartz IR. There's lots of there's no hermetic seal involved. It's just structural ribs, and there's lots of them inside of the part, and you hit that thing with a blanket of heat and then bring the parts together.
Center consoles, there's a couple of OEMs that specify IR welding, and Quartz is the sort of method to do that because you have a lot of them and you can't really see it, so it's just sort of a shotgun blast of energy.
Yep. Washing machine tubs, large industrial containers. If it can't be hot plate welded, Quartz IR sometimes is the right way to go for something like that. InfraGuide applications. So again, air ducts. The video that we saw of InfraGuide, that is an air duct inside of a vehicle, and so those often, the weld line becomes a little bit more complex, especially if it's in an engine and it's got to navigate through a certain path. Battery cases we've done InfraGuide on battery cases. Filters, that's what's shown on the screen there. It's an even more interesting type of application. So this is, I'm going to zoom in so you guys can see it a little bit better. This is a filter, a pleated filter, and we're using InfraGuide to heat that cap on the bottom, and then the filter gets embedded. It's not really welding, right? So it's just embedding itself into. We have
done compatible filter materials with housings or caps like this. Mm-hmm. But this is the application for it's quite niche, right? And this is actually glass filled nylon. We very, very tricky application. Mm-hmm. We've done others too where we have to get a whole bunch of melt to make sure that plastic goes up and seals the filter off correctly. But this is eliminating, an epoxy or a glue type of situation.
Do we measure the weld surface temperature before we weld?
Great question, Max. So
depends if you want it or not.
It depends if you want it. If it's critical to you, we have solutions for that. Thermal imaging is one option. We've also done point measurements. So we've used pyrometers that are actually really cost effective, just checking one point on a surface. So there's a couple different options for that. It is an interesting question because as you consider vibe welding or hot plate welding, there's sort of other quality parameters that you can measure. With IR welding, to sort of make sure that you got good melt, thermal imaging is a really, really good option.
Mm-hmm. Some other InfraGuide applications, small engine fuel tanks, things where you really don't want to do any kind of friction type welding. And there maybe the material is restrictive, so you can't use hot plate welding. That's where InfraGuide really shines. Yeah, that's what you did there. Okay. And then electrical housings. Next, non-contact hot plate welding applications. This is the image that Nick was referring to. This has got flash traps, so you can't actually see the weld, right?
That is included. That was I would call that more of like a gap. There wasn't a flash trap on this one.
Really?
There's not a flash trap.
Okay, let's zoom in so everybody can see how great this is.
This was a consumer product. Obviously, we're sort of hiding what the overall image is, but I think our seal depth was like 4th Allen on that. So you can kind of see ever so slightly what that weld rib is, and essentially the rib was just inboard, sort of inside of that outer surface. So that was quite a remarkable weld that we did, and it was a really unfriendly polycarbonate that we had to switch to from hot plate welding to non-contact.
I was trying to draw on this, but Microsoft won't let you use the pen and zoom at the same time. No. Okay.
Be better, Microsoft.
So that is our what was this? It's a thing. I don't know.
Yeah, I don't know that I can actually
Okay.
say
Who asked about automotive Kalash? I don't know I'm sorry, I don't know how to say your name. Automotive lighting is a non-contact hot plate welding way to do it. Fuel tanks, pallets, large batteries, and direct laser applications.
Can we go back real quick?
Sorry.
No, it's okay. So one key thing we've seen on this is you have essential to have low open time and high temperature. Ideally, we're shooting for 1,000 degrees Fahrenheit, and that gives you a little bit more window. So we've had some pretty, there's different tooling methodologies. We've had some that are not able to reach those temperatures, and we've had others where we have a welding platform that we need to make sure we get to that can run that high.
Does the hot tool actually start glowing when it's that hot?
It has a very faint, around 1,100, 1,200, it has a very faint glow. Yep.
Sweet.
Things can break when you get that high.
Yeah.
So you have to engineer it correctly.
Yep. Because if something did you guys know that there's a thing called thermal expansion? And when heated tools get hot, they get bigger. And you got to deal with that.
So you got to deal with that.
That's what we're here for.
That's right.
Direct laser applications. The fluid channel there, you see, beautiful part. It's a small thing. Plastic connectors, ports, medical devices. Somebody just dropped something in the chat.
Yeah, you keep going.
Okay.
Yeah.
So these are all fairly small. I think the common thing for a lot of these is that there's some fluid involved. It's really a great solution for that. We like using direct laser in some of these because you can imagine these small parts with these weld ribs that are close together, yet they don't want, InfraGuide's too big to fit in such a small application. And then Quartz IR, some of these you can't blanket the whole part with energy. That's not okay. And so you could maybe use non-contact hot plate welding, but if you want something more precise, more sophisticated, direct laser welding is the way to go for some of this stuff.
So the image that was just dropped in, thanks Max for that. I would say it's in the vibration weld range. Maybe close to laser, depends on where and other implications. And what I would say to that is when you're designing your parts, just make sure your weld rib is the correct width for the strength that you need. And our team can help you with that. Yep.
All right. Are you ready to make an introduction?
Yeah. So you might say to yourself, what do you run all these technologies? What kind of equipment do you run technologies like this into?
The answer is Extol's new Titan series welding platform. Dun, dun, dun.
If you're familiar with Extol, our Rapid Conductor is our hot plate welding platform that we've had in the industry for almost 20 years and has really established servo hot plate welding. There's many other companies that do that now. We've redesigned the system, that system. We've taken a lot of the great feedback we've had over the years and some constructive feedback, and we've implemented it in this new system, which will allow you to customize the heat source that you need with hot plate, InfraGuide, and Quartz IR. You can choose which system you have when you purchase it, if you just want hot plate, or you just want InfraGuide, or you just want Quartz. And then we're also going to have a configurable system that has multiples of those, so you can do all the above if you'd like.
Mm-hmm. So this thing, it's going to keep your uptime high and maintenance low because it's a robust solution, just like the Rapid Conductor. We've gotten really good feedback from customers that those machines just keep running. They can't die.
Literally, customers have said, my only criticism is I can't justify a new one because your machine is 11 years old with 1.8 million cycles and just keeps going.
Yeah. And this will be no different. Reduces capital and operating costs across multiple programs because you've got this one platform that you can fit all kinds of programs in, regardless of whether they need hot plate welding or IR welding. So you can really spread that the wealth around when it comes to your capital. And then it can be configured for multiple welding technologies. So it's got flexibility and it scales easily as your production needs evolve. So maybe you do just buy a Titan welder and you want to use it for just hot plate. But then as time goes on, you have an IR welding application and the machine can be configured to add those capabilities. Did somebody just drop something in here?
We got a couple actually. How long after the molding before welding? Thinking post-ejection shrinkage. That's a really good point, Alan. And most of our customers will do an offload from the mold on a conveyor to allow it to cool slightly.
But you don't have to.
But you don't have to.
You can weld hot parts.
You can weld hot parts, but your tool has to fit them correctly.
Yeah.
And so it's all about matching, and that if your part's this big, that shrink, percentage wise isn't, there's percent and then there's actual linear, what's actually happening. Really large parts, those things really need to be dimensionally consistent. That's just kind of the name of the game. And then
he's talking about hybrid welding where there's IR plus vibration. So what that is you do an IR weld preheat to your plastic parts and then you vibe weld after that. And that is a way to improve appearance of your weld, and it also in some cases can increase the strength of the weld. Cycle times can be pretty long because you are essentially doing two different welds sequentially.
Right.
So we have a partner in Italy that actually provides those welders.
Yep.
You have sample of multiple parts welding to improve cycle time. Need to have 10 to 15 second cycle time. Maybe we'll follow up with you afterwards,
Dimitri. I think that's a really good, that sounds very challenging. 10 to 15 seconds. That's a lot of parts. What we'd like to follow. That's not uncommon for us to work with that kind of thing. Mm-hmm. But I just saw we've got our 5-minute warning that just popped up.
Oh, boy. Okay. So the Titan series welding platform, it's a shared platform that reduces capital costs over time. It gives you optimized weld quality for every material. It allows you to have accelerated development and process proving. Yes, because we can make these machines very fast. Mm-hmm. Like how fast, Nick? Putting you on the spot.
10 to 12 weeks.
Okay. So
that is not what we have heard the industry standard is.
And it's reduced downtime and simplified maintenance because these things are robust and they don't break. There's cost reduction across the life cycle because we can do all these different welding technologies inside of one machine. And it's a scalable, future-proof investment. So here's some pictures of one of these welders that's currently being built on our floor. So these are two pictures side by side. The one on the left shows the doors open, and actually the front guarding panels on the top and the bottom of the machine have been removed so that you can actually see the ball screw in there. There's a ball screw on the top and
we have a load cell in this one. We have a high precision force option for this system, which we did not have for our rapid conductor.
So I'm gonna show.
We have great weld by force control.
Where's the load cell?
It's got the wire running to it.
Okay, yeah, the wire about in the middle of the screen there. That's your load cell. So that means we can. What does a load cell really do for us?
So great question. We can do force control with the servos that we use. However, the resolution, they're really repeatable, but the precision isn't excellent. Really under like 200-300 pounds. So if you really need that sort of precision, we have that as an option.
This is what the the energy shuttle, right?
Mm-hmm. That's what we call it.
If you're familiar with the rapid conductor, there are heaters inside of the platen, and then you clamp heated tooling onto it, and then the heat conducts into those tools. Here, we have the ability to do it that way or this way, where we have a carrier and it's got pockets machined out of it to try to reduce the weight but keep structure. And then the tools themselves would have heaters in them. So that gives us the ability to be flexible. We can pull those out and we can do IR, we can do hot plate. This is what the control box, I don't know what you call this thing.
The energy
box.
We call it. So this has connections for all three technologies, direct laser, not included, quartz, hot plate for either contact or non-contact, and InfraGuide. And so it's a quick connect. If you need a quick change option, we have that. You'll notice the airlines there. That is for the InfraGuide tooling, and if you needed to have cooling on quartz.
Yeah. And then Kenneth mentioned the transformer. Yep, there's a Hammond transformer. Sure.
Yep, that's fine.
So the Extol Titan Series welder, get yours today. There's my sales pitch.
Dimitri just said something interesting real quick. So this is one standard machine. However, we've done all these welding technologies in custom machines. So if you need to, I think Jason alluded to this a little bit from a integration system. If you need a completely custom setup, that's honestly probably as common, if not more common, than the standard machines. So don't just think of us in terms of what you see on the screen. That's one half, so to speak, of our business. The other half is, I think someone asked about a multi-cavity 3,000 parts per shift sort of setup. We've done hot plate welding systems, not so much maybe with quartz, but you can hit it with multi-cavity tools. We have done multi-cavity infrared welders. So we're going to tailor that equipment solution to your application.
Yep. Have we done any testing research on weld quality depending on the part's surface temp before shooting IR? Like
we have thermal imaging capabilities in house. I wouldn't say we've done a study exactly like that.
Yeah, but
if you need that, I'm very intrigued. That's a really good question.
How much is the base without the welder? Wait. Base without the welder.
Oh, list price.
Yeah, but what without the weld? That is the welder.
Yeah, I think I'd say without tool.
Oh, okay. Yeah.
We have different we have two different sizes. I don't know that off the top of my head, to be honest. Yeah.
How much would you pay for it?
That's right. A question with a question. I'm sure Kenneth loves that. Kenneth, we'll get that answer to you afterwards. Yep. Dimitri, I just saw that you mentioned dial tables. We have also done welding systems with dials. So
yes.
Great interaction, you guys. Thanks for spending an hour with us. I didn't see too many people fall off, so that's great. And Jason.
I'm going to take the link that's on the screen. At least I'm going to try to. Actually, maybe if I just click on it. You can sign up. You can just go straight to our website to do this, but I'm going to give you a link so that you don't have to type anything. There's a link. You can go sign up for the next webinar. That'll be July 16. It's all about designing parts for nanostake. So we'll talk, of course, we'll do answers to your questions just like today. We'll talk about plastic staking basics and how nanostake works, and then really get into the nitty gritty of how to design your plastic parts for nanostake. Other questions? Does Extol support welding like IR or hot plate welding for the low volume product? Oh, not like contract manufacturing, I think. And yes, we can do contract manufacturing. So if you have low volumes and you don't want to invest in the capital equipment, we may be able to help you with that. We're not a full-blown contract manufacturing company, but we do contract manufacturing for several different.
We've done in the tens of thousands, upwards of north of 50,000 parts. So we can definitely do that. Look at different quality, analysis before things ship and so on.
Yep.
Great.
Awesome. Any final parting shots? Otherwise, we can wrap this bad boy up and let you guys all get to lunch if you're in the Eastern time zone. If not, then you can't have lunch yet. Not allowed.
Thanks, everybody. Appreciate
Thanks for joining. See ya. Sure.